Hello, in this video I'm going to explain to you section 5 of chapter 7. In section 5 we are going to be calculating in right-angled triangles. So you should know something about a few triangles. But first the right-angled one, and there's a picture over here. We call this a right-angled triangle because of this symbol. This symbol means that angle Q is a right angle, and the right angle is always 90 degrees. So triangle PQR is a right angle triangle, and that's a really important one in this chapter because trigonometric ratios such as sine, cosine and tangent can only be used in right angle triangles. The same goes for Pythagoras' theorem. This also can be used only in right-angle triangles, so be aware of that. Some other thing what's really helpful to know is the sum of the angles in a triangle is 180 degrees, and sometimes this rule is very helpful in this whole chapter. So make sure you do know these things. So is the right-angle triangle the only special triangle? And the answer is no. There are two more special triangles, and I'm going to show you which one. First, the isosceles triangle, and we've seen this in year 1. What is an isosceles triangle? It's a triangle with two equal sides, and it's also shown in the picture by using the same symbol inside AC as you see in BC. So you could write down AC is equal to BC because they have the same length. But also there are two angles that are equal, and again you can see this by looking at the symbols. They are there for a reason, the symbols. So you could write down angle A is equal to angle B, and because these sides have the same length, you are allowed to use the symbol for equal, and the same goes for the angles. But the triangle again has a third angle, and that's angle C, and in this case it has a special name. In an isosceles triangle, the two angles that are equal are called the base angles. So angle A and angle B are base angles. The third one is called the apex angle. It's angle C over here. And what's really good to know, when you have an isosceles triangle and you draw this line, the axis of symmetry, you divide the isosceles triangle in two right-angled triangles. So be aware of that. And those two triangles are the same. And both triangles are right-angled triangles, and this will be very helpful in some of the exercises. There's one more special triangle, and it's called the equilateral triangle. And when you take a look at all the symbols in this example, this means that side EF is equal to FG is equal to GE. So all the sides have the same length. Same goes for the angles. You see, the angles have all three the same symbol, and this means that all the angles are equal and must be 60 degrees because the sum of all the angles is 180, and 3 times 60 is 180. So you could also write down angle E is equal to angle F is equal to angle G, and all are 60 degrees. So this was the third special triangle you need to know about. So then, what's next? What are we going to do in this section? Well, you have to do a lot of calculations on right-angled triangles, but maybe sometimes they are not right-angled. And then if there isn't a right-angled triangle, you have to draw one yourself. So maybe you need an extra line to make, for example, a right-angled triangle. On page 18 there's a method in your book and it helps you to solve these exercises. Let me remind you that it's always really helpful to make a sketch, and then this will help you to solve the exercise. What's also helpful is the donkey bridge for the trigonometric ratios. So, K, Toa. Het ezelsbruggetje in het Nederlands. Dit zijn dus niet de formules zelf, maar ze helpen je om de formules te onthouden. So, for example, we have to calculate side BC. That's that one. And when you take a good look at this triangle, you should know the side, the longest side, and always opposite to the right angle, is the hypotenuse. So we need to calculate the length of the hypotenuse. So I do need a formula that has the hypotenuse. Otherwise, I won't be able to calculate the length of the hypotenuse. So this means I won't be using tangent, because it doesn't have the hypotenuse in the ratio. So now we have to decide either to use sine or maybe cosine. So, well, let us take a look at the triangle. I do know an angle, and I do also know one of the sides. And we are asked to calculate the length of a side. So, well, if I only know angle B, I probably should use angle B. So, suppose you are standing over here. Then we take a look at AC. Just think, is this an adjacent shorter side of angle B, or is this the shorter side, the opposite shorter side to angle B? And it's the last one. When I take a look from angle B, this is the opposite shorter side. So I do need a formula that has the opposite shorter side and also the hypotenuse. So the only possibility will be, I'm going to use the sine formula. So let us write this down. Sine of angle B, because it's the only angle I know, is the opposite shorter side, AC, divided by the hypotenuse, BC. So this is what we're going to use. So when you have decided that we are going to use the sine formula, just take some time to fill it in. Fill it in completely. Don't leave anything away. So I do know angle B, that's 22 degrees, but I have to copy the word sine. So sine of 22 degrees, then AC, 13, divided by BC. So this is what we do know, and you see, we know two things. We know an angle, and we know one of the sides. And this one can be calculated. So you're going to write down BC is equal to, but then we have to write down a calculation for BC. How do we do that? Do we need to divide or multiply? Then, if you don't know, always use an easy fraction. 2 is the same as 6 divided by 3. So this 3 is in the same position as BC. Over there. So what we're using something we know. How can I calculate 3? By using a 6 and a 2. Do you need to divide or do you need to multiply? And of course you do need to divide. So we're going to do exactly the same. I want to calculate BC the same as we calculated 3. You had to divide. So over here we do exactly the same. 13 divided by the sine of 22 degrees. So you can use your calculator to calculate the length of BC. We're going to round it to a whole number. No, we're going to round it to one decimal place. And then you should find 34.7, and this should be a point. So we're going to make a point out of this. So it looks like a point a bit more right now. 34.7, that's the length of the hypotenuse. So in this section, please, if it's difficult, make sure you do have a sketch. Write down everything you know. Use the donkey bridge. Gebruik het ezelsbruggetje. But also in the last step, use a fraction you know, an easy fraction to see in your last calculation if you need to divide or maybe you need to multiply. And then you can find your answer by using your calculator, because you cannot calculate this without a calculator. Last tip, use method on page 18 in your book. Read it and take a good look at the example in your book. This can be very helpful. Good luck with your exercises of section 5.